PSC member will have good higher shear resistance compared to the RCC members. Then high use of high strength concrete and high strength steel results in smaller cross section. Okay, because of use of high strength concrete and high strength steel, the cross section of the member will be smaller. Cross section of the member required to resist the loads will be smaller. Okay, that will result in more economical sections compared to RC members. More economical sections in terms of sectional dimensions, I'm telling, not in terms of cost. Okay, when it comes to the cost of the PSC member will be higher than cost of the RC member. Okay, don't get confused with this sentence. Most economical section in terms of sectional dimensions, not in terms of cost. Okay, most economical sections compared to RC members. When you compare the cost of PSC members will be high because the pre-tensioning system or the post-tensioning system is there, no? That itself will require higher cost. Okay, that is why it will result in higher cost compared to RC members. Okay, so more economical section in terms of sectional dimensions. Okay, compared to RC members. Then coming to the speed of the construction, it will have rapid construction and better quality control and reduced maintenance. Obviously, the precast element can be directly brought from the place and they can be directly installed into the site. Okay, no need of any farmwork, no need of putting the reinforcement, no need of putting the concrete, no need of curing, nothing. Okay, you can bring the on-cast PSC elements, okay, from the plant, then you can directly install those elements and you have to take some care at the joints between structural elements. That's it. Okay, but obviously it will reduce the time. Okay, the construction will be rapid and quality control will be good compared to RCC structures. Okay, and maintenance cost also less. Then availability of standard shapes and sizes. Okay, the robustness will be maintained with respect to the shape and the size of the PSA element. Okay, the perfect size and perfect shape will be maintained, and different shapes of the PSC members can also be casted. Okay, these are all few advantages associated with this PSC or prestressed concrete. And there are some disadvantages associated with this PSC. That main disadvantage is it needs the skilled technology. It needs skilled labors. Okay, it is not like conventional construction. Okay, it is a special construction wherein the special care has to be taken. Some skill sets are required. Okay, simply you cannot cast prestressed concrete elements. It requires skill, it requires skilled technology, it requires proper machinery, okay, proper prestressing systems it requires. That is only the main disadvantage of this prestressed concrete. Okay, so it requires skill technology. So hence it is not common as reinforced concrete. That is why in most of the smaller constructions, residential constructions, will go for conventional reinforced concrete rather than going for prestressed concrete. Okay. Now coming to the next disadvantage of PSC, the prestressing requires, as I said, some special equipments like jacks, anchorage, etc., which pretends the use of prestressing. Okay, some advanced equipments are required for prestressing process that will make the user to not to go for this prestressing system. Okay. Then coming to the next disadvantage, high tensile steel is required for prestressing. That is very difficult to procure. They are costlier than the normal reinforcing steel. Okay, this high tensile tendons or the cables are there. No, they are having higher cost compared to this normal reinforcement, which is used for RC structures. Then, as I said, it requires highly skilled workers and should be prepared under expert supervision. Okay, skilled laborers or skilled workers are required for this construction of PSC. Okay, and coming to the cost comparison, it is costlier than RCC structures due to the use of high strength materials and other additives. High strength concrete means not only the conventional materials used in the high strength concrete. To achieve that high strength, we have to use some chemical admixtures. Okay, we have to use some mineral admixtures. Okay, because of use of other additives other than the conventional materials, it will result in higher cost. And some advanced equipments, okay, jagging devices, okay, and cost of this uh, tendon is also more. Okay, including all these things, the PSC will result in higher cost compared to RCC. Okay, then coming to the last disadvantage, with respect to the fire resistance. When you compare the fire resistance of the PSC and RCC, the fire resistance of the PSC elements is less compared to the RCC element. That is also one of the disadvantage with the PSC. Okay, disadvantage with the prestressed concrete. Okay, I hope you all understood on all these points of advantages and disadvantages of PSC. Next, we will see what is the difference between pre-tensioning and post-tensioning. Can anyone tell what is the difference, main difference between pre-tensioning and the post-tensioning? Just before in the first hour I explained the method of pre-tensioning and the post-tensioning. Can you tell what is the major difference between both the methods? Pre-tensioning and the post-tensioning? What is the major difference? I have seen I have shown you the video also, correct now? Post-tensioning process and pre-tensioning process, and I have explained both the methods. Anyone can tell the difference between pre-tensioning and the post-tensioning? It is most commonly asked question in your examinations. As you can see, just by seeing the titles, okay, pre-tensioning and post-tensioning, we can define the difference, correct? Pre-tensioning means the tendons will be stretched prior to application of the concrete, prior to pouring of the concrete. That is a thing involved in pre-tensioning. In case of post-tensioning, after the concrete being poured and hardened, the tendons will be placed and stretched and stresses are induced. Okay, that is the thing involved in post-tensioning. Okay, the same thing is written in the first point. In this method, the concrete is pre-stressed with tendons before it is placing in position. Okay, concrete is pre-stressed with tendons before it is placing in position. In case of post-tensioning, the pre-stressing is done after the concrete attains sufficient strength. There is a major difference between the two. Okay. Then coming to the development of the pre-stressors. Okay. In case of pre-tensioning, the pre-stressors will be developed due to the bonding between the concrete and the steel tendons. Okay. The pre-stressors are developed due to the bonding between the concrete and the steel tendons. In case of post-tensioning, it is developed by anchoring at the edges. Let me go to the both the methods, pre-tensioning and post-tensioning. Here you can see there is direct contact between concrete and the tendons. That is why the pre-stressing will take place by the bonding between the both tendon and the concrete. In case of post-tensioning, the pre-stressing will take place by properly anchoring the tendons at both the edges. Okay, that is also one of the difference we can observe between pre-tensioning and the post-tensioning. Okay. Then coming to the next difference, pre-tensioning is preferred when the structural element is small and easy to transport. Okay, and the post tensioning is preferred when the structural element is heavy. Okay, usually for this precast elements, no, in precast industries. Okay, precast industries. In most of the precast industries, they will go for this pre-tensioning. Okay, if a member has to be pre-stressed on site, okay, which is having some uneven shape, okay, or size, okay, then we'll go for normally we'll go for post tensioning. If you want to do in most of the precast industries, they will go for this pre-tensioning. If a member has to be stressed or a pre-stress has to be induced into the member on site, then we will go for this post tensioning. Okay, that is also one of the difference we can observe between the two. Okay, then coming to the cost, it is cheaper because of the cost of sheathing is not involved. Okay, cost of sheathing means the duct. Here we have to place extra duct for post tensioning system. You can see initially the ducts will be placed. Okay, after that concrete will be poured, hardened, and after that inside the duct the tendons will be taken. Okay, in case of pre-tensioning system it is not so. Correct. Without duct directly there is contact between concrete and the tendon. Therefore, doing the cost comparison, cost of post tensioning system is higher compared to the pre-tensioning system. Okay. Then coming to the reliability and the durability. Reliability means what? What is the meaning of reliability? Ability of the structure to perform its intended function is called as reliability. Correct, no? Ability of the member or structure to perform its intended function throughout its life cycle is called as reliability. When you compare reliability of this pre-tensioned element and the post-tensioned element, the reliability of pre-tensioned element is higher than post-tensioned element, and durability is also more. Okay, pre-tensioned element is more reliable and durable compared to post-tensioned element, because this pre-tensioned element, no, uh, most of the precast industries they will use, there will be a standard setup. Okay, and it will be a permanent setup where the more quality will be maintained with respect to the size or operations. Okay, with respect to the labors or quality of the materials used. Okay, some quality will be maintained. That is why we will have a more reliable and durable member of pre-tensioned element compared to post-tensioned element. And just before I was discussing about loss of pre-stresses. Okay, what are the stresses induced? Pre-stress induced. 100% pre-stressing it is not possible. Okay, there are some loss of pre-stresses due to the friction, due to the relaxation of the steel, or due to the quality of the materials used. Okay, because of that there are some loss of pre-stresses. When you compare loss of pre-stresses, the loss of pre-stresses in case of pre-tensioning is little higher than loss of pre-stresses in case of post-tension element. It is about 18% for pre-tension element, and it is about 15% for post-tension element. These are all the major differences between pre-tensioning and the post-tensioning. Okay, so in these points, if you have any doubts, you can ask. Otherwise, I will move on to the next topic. That is difference between RCC and the PSC. Any doubts? Okay. So difference between RCC and PSC, we can list several points when it comes to difference between RCC and PSC. Correct? What is the major difference between RCC and PSC? Major difference, as we have seen, pre-stresses are induced into the PSC element, but pre-stresses will not be induced into the RCC element. That is a major difference. Okay. Other than that, we can list so many other differences that we will see now. Okay, fatigue limit is low for RCC and fatigue limit is high. What is the meaning of fatigue, students? What is the meaning of fatigue? Fatigue. Fatigue limit. Fatigue means the resistance to the continuously applied load for longer duration. Okay, resistance offered by the member for continuously applied load for longer duration is called as fatigue. Okay, fatigue takes place for a longer period of time. Okay, that is low in case of RCC and that fatigue limit resistance is higher in case of PSC. Okay, then in case of deflection it differs more compared to PSC. Deflection is very less in case of PSC compared to RCC. Okay, and it is observed that the deflection of PSC beam is equal to 1/4 the deflection of RCC. Okay, deflection of PSC element will be almost 1/4 the deflection of the RCC member. And coming to the cost, material cost is low for RCC members, but it is high in case of PSC members. Then coming to the behavior of the steel. Okay, behavior of the reinforcement for RCC and behavior of the tendons for PSC. Let us see. Mild steel and deformed bars are used as reinforcement for RCC. For PSC, high strength tendons are used. High tensile strength tendons are used. Okay, and these tendons are made from high tensile steel in the form of a single wire or multi-wire strands. They may have a group of wires or a single wire having higher diameter or larger diameter. Okay. As I said in the beginning itself, the no internal stresses induced in RCC, but internal stresses are introduced prior to the loading in case of PSC. Okay. Then coming to the cracks propagation, tensile cracks are visible. Okay. There is more probability of occurrence of cracks in case of RCC members, but the probability of occurrence of cracks in case of PSC members is very less. Almost no tensile cracks. Coming to the self-weight of the member, RCC member is higher compared to self-weight of the PSC member, because in case of PSC member we will use high strength concrete. As we are using high strength concrete, it requires low volume concrete to counteract the external loads. That low volume concrete used will result in low self-weight. Okay. Then for RCC, no quality control is required. It is a conventional construction. Okay. You can adopt the conventional procedure or conventional steps for casting casting RCC member, but in case of PSC member, a special control and special equipments, okay, skilled laborers are required for construction. Okay, RCC members need shear reinforcement, but shear tension is restricted by the tendons will itself offer resistance for the shear force acting on the member. Okay, tendons will itself take care of the shear force, but in case of RCC, the special shear reinforcement has to be designed and has to be implemented. Okay, then coming to the concrete, for RCC we will use normal concrete, for PSC we will use high strength concrete. Okay, high strength concrete is not required for RCC and high strength concrete is required for PSC. Then coming to the brittleness, RCC member is less brittle compared to PSC member. Okay, RCC member is less brittle compared to PSC member, because we are using high strength concrete. No, it will have good high strength. Okay, when stresses in the high strength concrete reaches its limit, then it will show brittle behavior. Okay, it will show brittle behavior when the loads will reach to ultimate value. Okay, these are all a few differences between RCC and PSC. Okay, so any doubts you can ask in this part. Before going to the next topic, that is different anchoring devices. Different anchoring devices. Okay, these are all very common points. Okay, there is no more technical aspects in this. You can write in general. Correct now? Okay, we'll move on to the next topic. So as I said, for post tensioning, the tendon should be properly anchored at its edges. Correct? For post tensioning process, the tendon should be properly anchored at its edges. For anchoring these tendons, no, there are a few anchoring devices used in the industry. Okay, there are a few anchoring devices used in the industry. Okay, let us see one by one. That is Prestressed anchorage system. Prestressed anchorage system. Prestressed anchorage system. It is developed by the France. Okay, and it is used more most commonly used method in pre-stressing system. Okay, so you can see in this figure there is a fluted male cone. Okay, it is a cone shape. A cone shaped element is there. Okay, in this cone element the high tensile wires will be placed. Here we have some grooves at this point. Okay, at this point multiple wires will be held, okay, with proper grip, and the tensile wires will be stretched to the required degree and properly anchored. Okay, so it will have a fluted male cone, okay, through which the tendons will be taken. Okay, and here we have some gripping system where the tendons will be properly gripped, okay, and stretched to a required degree, and stress is released. Okay, this is what the procedure involved in Prestressed anchorage system. Okay, through these grooves, okay, the tendons will be properly held in position. Tendons will be properly held in position, and they will be stretched to a required degree and released so that free stresses are induced into the concrete element. Okay, this is what the Prestressed anchorage system. So this figure writing the neat sketch is very important, and you can give some explanation. Okay, you need to remember all these sketches. The next type of anchorage system is Gifford Vidal system. Okay, which is developed by Great Britain. Okay, in case of Gifford Vidal system, you can see a split cone here. Okay, detailed sketch is written here. This hatched portion is there, no? Hatched portion. It is called as split cone. Here you can see some opening. Okay, here you can see some opening. At this opening, we have a female cone. Okay, this one. This part is called as female cone. Okay, inside this split cone, this female cone here, this portion, female cone will be placed, and inside this female cone, the wires will be taken. Wires will be taken, and this whole assembly will be held in position so that wires will be stretched to a required degree and released so that the stresses will be introduced into the concrete element. This is what the Gifford Vidal system. Okay, then coming to the next system, magnet Blaton system, which is developed by Belgium. Okay, Belgium. Here, this is a different kind of a unique system used to anchor the tendons. Here you can see the sandwich between two plates. This portion is there, no? This portion between this portion, the tendons will be taken. Okay, at here, here, and here. Okay, there is a sandwich between two plates, and there is a gap. Okay, in that gap, the tendons will be taken, okay, and here the tendons will be held in position and stretched to a required degree and released so that the stresses will be induced into the concrete element. Okay. Then coming to the BBRV system. BBRV means all these letters stands for the engineers. Okay, Swiss engineers. That is Birken, Brand, Istin, Ross, and uh, Watt. Okay, these are all the engineers developed this BBRV system. This is also most commonly used system. So this is in this system. About 90 to 170 wires can be simultaneously stretched and anchored through this system, and load of about load up to 12,000 kilonewton can be given for the tendons. Okay, that is why it is most commonly used system in construction practice, and it consists of several parallel length of high tensile wires with each end terminating in a cold formed button head with a machined anchorage fixtures. Okay, so when the desired extension or desired stresses or desired stretching of the tendon is done, then this at the head, no, at the beginning here, the tendons will be uh, screwed properly so that they will be held in position, and proper pre-stressing will be applied into the concrete. Okay, so this is about BBRV system. Next last kind of system is Lee-McCall system. Lee-McCall system. So this system comprises high tensile bars of diameter varying from 12 to 40 mm, which are threaded at the ends. Okay, here you can see. Okay, here you can see a high tensile steel bar. Okay, steel bar, and here you can see a plate. Okay, end plate. This portion is called as end plate. And here we have the concrete block. This portion. So this portion is concrete block, and the tendons will be properly stretched. Okay, washer, the end plates will be placed. Okay, after the end plate, by using nut and the washer, the tendons will be properly threaded so that they will be held in position, so as to apply the required stresses into the concrete block. This is what the procedure involved in Lee-McCall system. Okay, so these are all different anchorage systems used to anchor the tendons in post tensioning system. Okay, so you need to practice all these figures properly. Okay, figures are very important. You have to write the neat figure, and you need to give some basic explanation about all the processes. Okay, if you just observe the figures neatly, okay, if you just study the figures properly, then you will get an idea. Okay, idea about the process involved in anchoring of the tendons, stretching and anchoring of the tendons. Okay, then coming to the materials used for PSE, there are two main materials which we are going to use. Which are those materials? One is high strength concrete and high strength steel tendons. Okay, so as we are using high strength concrete, we should be aware of what are the different properties of the high strength concrete, what is the nature of stress strain curve for high strength concrete. Correct? So knowing all these things, we can implement it in an effective way in the PSC member. Okay, what are the different properties of the high strength concrete? In concrete technology subject, you have studied this. Correct now? Properties of high strength concrete. High strength concrete, as the name itself indicates, it will have high strength, high compressive strength, and split tensile strength, and the flexure strength. And it will have high modulus of elasticity. Stiffness of the concrete will be higher, and creep will be lower, and shrinkage will also be lower. Okay, means reduction in volume on drying will be lower. High resistance to freezing and thawing, chemical attack, then high abrasion resistance, durability will be higher compared to normal concrete. These are all the properties of the high strength concrete. When you study the stress strain characteristics of the high strength concrete, so this is what the nature of stress strain characteristics we get for high strength concrete. Here we get total three portions. One is straight elastic portion, next is breaking point or maximum stress point, and descending portion or the failure portion. Okay. In case of elastic portion, what is the nature of behavior of the concrete? In case of elastic portion means up to here almost straight portion. Stress is directly proportional to the strain. Correct now? Up to the elastic limit, the stress is directly proportional to the strain. Okay, and if you release the load at any point below the elastic limit, the material regains its original position. Okay, that is what the thing involved in straight elastic portion. Then coming to the next portion, that is break point or maximum stress point. So, which is the break point? This is the break point, correct? Huh? This is the break point. So between this portion and this portion, it is called as break point. Between this portion, you can see, or you can see a permanent deformation or inelastic deformation. Material undergoes permanent deformation, and when the stress reaches to some limit, okay, then breaking of the element will take place, the breaking of the concrete will take place, or failure of the concrete will take place. Beyond that, descending order will get. Okay, means it will not take any much load. The load will goes on decreases, and strain will corresponding strain will also increases. That is what descending portion or failure portion of the stress strain curve. Okay. So this is what the study about the high strength concrete. Okay. Then one more important material which we are using for PSC is the tendons, high strength steel. High strength steel. You can see the graph which is written for all types of members, like for RCC member and the PSC member. Usually for a RCC member, which kind of bars we will use? Either we will go for mild shear or HYSD bar, correct? No? And for PSC member, we will go for using pre-stressing strand or pre-stressing wire. Okay. If you just observe the nature of stress strain relationship between the HOST bar and the mild steel and pre-stressing strand or the pre-stressing wire which is used in pre-stressed concrete, it will have more ductile nature. It is the pre-stressing wire or pre-stressing strand is able to undergo large deformation compared to the mild steel or the HOST bar. Correct? Huh? It is able to undergo large deformation, and even the ultimate load of the pre-stressing steel is higher compared to HOST bar or the mild steel which you are using in the RCC element. Okay, this is what the behavior of pre-stressing steel which is used in the pre-stressed concrete element. Okay, so to this the theory part of the module 1 is over. So from the next class you will be studying about the analysis of the PSC member. Okay, next part is analysis part. Okay, that will be that we'll do in the next class. Okay, students. So if you have any doubts in the portions which I discussed today, you can ask any doubts. It may be any doubt you can ask. Any doubts, students? Okay, we'll end the class for today and we'll continue in the next class. Okay, thank you.